Inequalities. Greater than or equal to the most fun you will ever have. An inequality is a mathematical sentence that just contains these signs. Greater than, less than, greater than or equal to, or less than or equal to. An inequality does not have an equal sign. That's all the term inequality means. Nothing fancy. Real quickly before we begin, let's just go over the vocab. I know you've learned this in 6th and 7th grade and growing up, but it's good to go over it real quickly before we get into how to solve inequality problems. The first thing that you need to know is that when you look at your inequality sign, most people think of it as the mouth. The mouth always eats the bigger number. So this would be a correct inequality right here. This, on the other hand, that would be an incorrect inequality because 2 is not greater than 3. So even though we're using variables now instead of two numbers, remember, the mouth eats the bigger number. So for this one right here, it says x is less than 3. And when you're asked to graph it, when you see a less than symbol or a greater than symbol, it's an open dot on the number, and you point the arrow. Since it's less than, anything on this line can be x because it's less than 3. It can be 2, it can be 1, it can be 2.99. As long as it's less than 3, it cannot be 3 as well. On the other hand, when you see a line underneath that's less than or equal to, so in this case, x is less than or equal to 3. The only difference, notice that the dot is closed. It is closed because since it can equal 3, the closed dot indicates that it can also equal 3. And then I just give you two examples for greater than. And this one, x is greater than 3 right here, and you'll notice when I graph it, same thing, but x is greater than 3. And then x is greater than or equal to 3, notice the closed dot again. Just to get some real quick practice on this, please pause your recording now and graph y is less than 3. All right, we take the open dot, we put it on the 3, and since y is less than 3, my arrow is pointed that way. Again, pause your recording and graph the inequality. This inequality states that m is greater than or equal to -7. So since there's an equal to sign, I put a closed dot and on -7. And since it's greater than -7, my arrow points in the bigger direction. It could be anything greater than -7 and also -7. This one is just in the form of a sentence, so please write the inequality and then graph it out. All right, we have v is greater than 2, so the mouth faces towards the v. And then it is a open dot, and it is greater than 2. There you go. Now again, we have word problems in the form, you just have to write an inequality for the word problems. I'll demonstrate how to do the first one, and then you will get some practice. So the first one states that you must be 18 years old in order to vote in the United States. So we can use any variable. We'll just use x. And since I have to be at least 18, that also means that I can be 18. So there will be an equal sign. X is greater than or equal to 18. You can be older than 18, you can be 20, 25, 80, doesn't matter. You just need to be bigger than 18. Here are 3 practice problems. Please pause your recording now and write inequality for these 3. All right, Q is not greater than 12, which means it could also be 12. So we have a Q, we have a 12. Since it's not greater than 12, we put the less than sign, but it can be equal to. The next one, the weight of the backpack can hold the weight the backpack can hold is less than 8 pounds, which means it cannot hold 8 pounds. So you can have any variable, x, b, whatever, and an 8, it is less than 8 pounds, so it goes this way, and that less than says it cannot be equal to. The minimum temperature for the mixture is negative 102 degrees. So I have my T, I have my negative 102. The minimum temperature, meaning it's got to be bigger, but it can also be equal to. There is the answer for that one. Now we're into one-step inequalities. I'm going to move through these pretty quick because we have a lot of practice with one-step algebra. You solve inequalities the same way that you do algebra, it's just a different sign. So in my one step, I have negative 6x is less than or equal to 33. Again, I just have to get the variable by itself. So I draw my line right down the middle, and to get the negative 6 and the x are multiplying, so I divide by negative 6, divide by negative 6. Now, I started with this one because this is your only exception. Whenever you are dividing by a negative number, this is the only time you will do this. But whenever you are dividing by a negative number, you flip the sign. So my sign is flipped. I have x by itself, and then when I do 33 divided by 6, 6 goes into 33 5 times. That gives me 30, and I have a remainder of 3. So my fraction would be 5 and 3/6, which reduces to 5 and 1/2. X is greater than 5 and 1/2. Remember, only when you divide by a negative number you flip the sign. Generally, you will not. I will demonstrate one more. This time the x and the negative 15 are dividing, so I have to multiply. Since I'm multiplying to undo, I do not flip the sign. Multiply by negative 15, multiply by negative 15. X is greater than or equal to 30. A negative times a negative is a positive. Here is your practice. Again, one-step algebra for these. Start with your line. Pause your recording now. Number 1. Start with my line. Just like the equal sign, the opposite of divide by 4 is times by 4. Times by 4. 16 times 4. 6 times 6 is 24. Here are the 2. That gives me 64. X equals a negative times a positive is a negative 64. Just like one-step algebra with an equal sign. Draw my line. The opposite of minus 13 is plus 13. Plus 13. X is less than or equal to 1. You write that more legibly. And then finally, the opposite of plus 21 is minus 21. Minus 21. Y is greater than negative 7. If you didn't get those right, and if you're still struggling, come see me or watch the chapter 2 flipped on how to do one-step algebra. Again, two-step inequalities is the same as two-step algebra. So, draw my line. Start with what's not attached to the variable. The negative 5 and x are attached, so I start with the minus 8. Minus 8. 23 minus 8 is 15. Again, stay on the line just like we talked about in algebra. It makes your organization very easy. And here is the trick part right here is we have to divide by negative 5. Divide by negative 5. Remember, whenever I divide by a negative number in my algebra, I flip the sign. 15 divided by negative 5 is negative 3. Second example is x divided by negative 8 minus 7 is greater than negative 8. Do my two-step algebra. I plus 7, that gives me negative 1. X divided by negative 8 is greater than negative 1. The opposite of divided by is times by negative 8, times by negative 8. X is greater than 8. A negative times a negative is a positive. Here are some practice problems for you. Please pause your recording now and go ahead. Let's go through these. Again, start with what's not attached to the variable. This is a positive 5. Don't mix up this negative. That goes with the negative. That goes with the 2. So it's a positive 5 minus 5 minus 5. That gives me a negative 12 is greater than or equal to negative 2x. Now here comes the trick. Make sure you notice when I divide by negative 2, I have to flip the inequality sign. So it'll go to this. I'm running out of space. That is x is less than or equal to negative 12 divided by negative 2 is a positive 6. That was a tough one. If you got that correct, great job. Number 2. The opposite of minus 12 is plus 12. Plus 12. That gives me 12 is greater than or equal to negative 4x. Got to get rid of that negative 4 times the x, so I divide by negative 4. Divide by negative 4. Again, I have to flip the sign. X is greater than or equal to negative 3. And your final problem is negative 2 plus x divided by 3 is less than negative 11. Draw my line. Plus 2, that's negative 9, and I have x divided by 3. The opposite of divide by is times by 3, times by 3. X is less than negative 27. Those are pretty difficult practice problems. If you got those correct, great job. If not, rewind, try again, or come see me. The final part of this lesson are the word problems. These are difficult word problems, but these will be something that you will see, something like this on an assessment. I'll read the first one out loud, and then I will give you a chance to pause the recording and solve it. John makes $7 per hour working at a pet shop. He wants to buy the new iPhone, which costs $225 after tax. How many hours does he need to work? Please write an inequality. That's the important part. Write the inequality and then solve it. Pause your recording now. All right, the inequality shouldn't be too hard to write for you. So if it's $7 per hour and we need to figure out how many hours that he works, my variable would go next to the 7. And then I need to make more than $225. And it could also be equal to, because $225 would give him enough to buy the iPhone. So to get rid of this, it's just basic one-step algebra. Divide by 7, divide by 7. We're going to need to do some long algebra for this. Excuse me, some long division. $225. 7 goes into 22 3 times. That gives me 21. Minus 1, 15. 7 goes into 15 2 times. So it's not a nice number, but 32 hours and 1/7 of an hour. So my answer is 32 and 1/7. But if you look at the problem, how many hours does he need to work? People generally don't work 1/7 of an hour. You work 8-hour days or something like that. So 32 and 1/7 hours wouldn't make sense. So he needs to work at least 33 hours. You round it up because if you work 32 hours, he wouldn't have enough money, so it needs to go up to 33 hours. My answer is 33 hours. That is a tricky problem, but it will be on an assessment, so that type of problem. The next one, you have a bag of flour that contains about 20 cups of flour. You make a batch of bread that uses 12 cups of flour. A batch of muffin uses 3.5 cups. How many batches of muffins can you make? Please pause your recording and go ahead. So the total cups we have is 20 cups. Whenever you see total, we kind of talked about this last week, but whenever you see total, that generally goes on by itself on one side of the inequality or equation. The most we have in this bag is 20 cups of flour. So 20, nothing can be greater than 20. So the inequality will face that way. And it can also be 20, so it's equal to as well. Now, we cook a batch of bread that uses 12 cups. So we're already done with 12 cups. And then it's 3.5 cups per batch of muffins, and we want to figure out how many muffins. So my variable would go next to the muffins. Make sure to keep muffins with muffins. Okay, so now we have an inequality, just a two-step inequality that we can solve. The opposite of plus 12 is minus 12. Minus 12, that is 8. All I have left on this side is 3.5. And then I have to divide 3.5, divide 3.5. Again, this is kind of a messy problem. So we can just use common sense. All I have left over here is x. 3.5 goes into 8 about 2 times. 3.5 times 2 is 7. So the question asks, you always have to put your word problems in context. How many batches of muffins? We do not have enough, since it's 1.5 cups, for a third batch of muffins. So you can make 2 batches of muffins. There you go. That is the inequality flipped. There's my information. If you need me, there were some tough problems, but you will be responsible for those on an assessment. Love you all. Have a great